Yeah, problem two is a lot more difficult, right? Because it's a law of sines problem. We don't have a right triangle anymore. We have these, you know, obtuse triangles or whatever, we got going on. So, what do you do in this situation? Well, first, take a deep breath. And the law of sines sometimes is easy. And they're easy when they're like this. Let's jump ahead for a second. Let's go to the packet that you just received yesterday, okay? Well, not easy. They're easier than some of the other ones. But if it's an angle side angle situation, it's a one triangle. There aren't any ambiguous situations going on. So this is an angle side angle situation because if this is 10 degrees, this is 80 degrees right here. All right, so we got an angle side angle, and we're going to have to find the length of the tree first. So let me put an X right here, and we would go something like this. We'd go the sine of 24 all over X is equal to this. Well, we don't really care about this side, so why don't we find this angle up here real quick? So 80 and 24 is 104. And so this angle right up here must be 76 degrees, right? So I'm going to go sine of 76 all over 60. And now we got to solve this, proportion. So, we're going to multiply by 60 and we're going to divide by the sine of 76. That would get the X all by itself, right? Like if you multiply both sides by X, multiply both sides by 60, go ahead and do that work. But I'm going to skip to this step right here. 60 times the sine of 24. 60 sine 24 divided by the sine of 76. And let's jump over to Desmos. Where did you go, Desmos? Right there. So we want 60 sine 24 over sine 76. So 60 sine 24 all over sine 76, wasn't it? Sine 76. All right. And so that comes out to be, wait a minute here. What did we miss here? 60 sine 24. Oh, I got a 6 in there instead of 60. I was going to say there's no way the tree is whatever it was before. 2.5 feet. Now it's 25 feet. Okay, so the tree is 25 feet tall, but they want to know from the top. Now, I mean, that would get you probably a 5 out of 6, but they're really looking for how from the top down to the bottom, what is that length perpendicular? Like if, somebody was climbing to the very top and then they jump down, it'd be a long jump down, I think. But we're going to do something like, let's see, this is the opposite leg. Now we're back to SOHCAHTOA, right? So this is the opposite leg. That's the hypotenuse. And we know the hypotenuse was about 25 something. So maybe I'll just set up the sine of 80 is equal to the opposite over the about 25 number. So, right, we got to multiply sine of 80 times 25 to get that length. So let's do that real quick. So I'm going to take, I guess, here's my length again, right? I can just kind of picture this is the height of the tree. And I want to multiply that height by, what was it, the sine of 80? The sine of 80. And so, right, I approximated as 25, but that was that monster right there. And so from the tip down to the ground, it's 24.8. 24.8. So I'm going to put 24.8 down here, 24.8 feet. Let me just check in their key. What did they do here? Yeah, they got 24 point. Oh, wait, are we supposed to round to something else? I got 3 decimals. How it doesn't say what to round to. So they put 24.769, 24.769. Oh yeah, they're putting all 3 decimals down on their key, which you're going to get the key on Thursday. So you'll see the drawings and all that kind of stuff for this one right here. So I started with this one because this is the one you got yesterday, and maybe you're panicked about that, or maybe this one really threw you off. Number 2, the second packet you got, they're missing some wording here. When I looked at the problem more closely, I'm like, wait, we don't have enough information to do this problem. It says a 20-foot statue. Okay, so we got 20 feet right here, and it says it makes a 25-degree angle if you're looking at the top of the statue. But then they're like, they don't say anything else. So, that's pretty bad on their part. They should have said there's a 100-foot ramp that goes to the. Oh, geez, let me try again here. There's a 100-foot ramp that goes to the base of the statue. So I'm going to put 100 right here. Okay. And if we knew that was 100 and we knew this was a 25-degree angle, this angle right up here, because you have a right triangle, down here to a right angle. So right angle 25. Let's see, that makes 115. Then this angle right up here would have to be what, 65. So if this angle is 65, now we could use the law of sines, and we have an angle. How should I say this? What I think we're going to do with this problem is, because the wording is messed up, and you saw it on the key and all that kind of stuff already. I'm not going to spend a whole lot of time on problem 2. I'm going to make sure the final that you're taking is not messed up like this one. That they're missing information. So unfair to do this problem. All right. So let's not worry about that one, and let's go to problem 2 from the first package you got. This one is a challenging problem because they say that you go at this a northeastern direction. Which, how do you know that's a 45-degree angle? I would specify on the final exam, hey, you got a 45-degree angle right there, right? The other thing that makes this problem difficult is you got a little side, big side angle situation, which ends up being a 2 triangle situation if the law of sines works, right? So like if you go the sine of 45 all over 2.5 is equal to the, we don't know angle right down here. Let's call it theta. Okay, so I'm going to go the sine of theta all over 3. Now, when I go 3 times the sine of 45, 3 sine 45, all divided by 2.5, and that's going to be my sine of theta. Remember, if we get a number over here that's less than 1, it means we have 2 triangles, right? So let's go to Desmos, and let's see if we can get this all on the same screen here. How can I do this? Okay, we can go like that. I chose the wrong one to go over there. Doggone it. Get over there. Right there. No. Oh, son of a gun. Let's see here. Here we go. I got right here. So I want 3 sine 45 right here. I want fraction 3 sine 45, and down in the denominator I want 2.5. And because this number comes out to be less than 1, we have a 2 triangle situation. So maybe in your drawing, just to help you out, you draw in the other side over here, and you say, hey, you know what I'm going to do is I'm first going to find this angle. Let's call it beta. And then I'll find theta over there. All right. So how do I find beta? I take the inverse sine of this stuff. I go inverse sine, and I get 58 degrees. Okay. So 58 degrees roughly is this angle right in there. 58 degrees. Now, remember, this guy right here can swing over because it's a little side and hit right here. So this would be a 58-degree angle here. So the way you find theta is you go 180 minus 58. So right in here, I'm going to go 180 minus that number, 180 minus that, and I get 121. See how this is a way tougher problem than the one that you got yesterday? So this is 121 right here. And they're looking for how far, what was it again? How far was the camper? How far from the campground was the camper after reaching the road? Oh, we're looking for this little distance right down here, that that thing I put an X on. So once I get 121 here and I got 45 here, then I'd want to find this angle right up here, right? I'd want to find the angle that's across from X. You see how, this one's way tougher than the other one. So how do I do that? Well, I add 45 to this number right here. So let's add 45. Let's put down 45 plus. And then that's the two angles added together, right? And then we would subtract from 180 this angle from 180, which seems kind of crazy. Like, we're going to go 180 minus all that stuff. So I go 180 minus, and if I put a parenthesis right here, it should work out, right? 13 degrees. Okay. So this angle right up here is 13 degrees roughly, right? And so now I'm going to do a sine of 13 degrees all over X is equal to the sine of 45 all over 2.5, right? And this is where you're going to go 2.5 times the sine of 13 and then divided by the sine of 45, right? To get the X all by itself. We're cross multiplying and then dividing by the sine of 45. So let's see, how can I manage that? I guess, you know what? I like how some of you guys do this. You go like B equals, and now we got B equaling that thing right there. And then, because that's what we want as accurate as possible, right? So I want to go sine of B times 2.5 divided by sine of 45. So I'm going to go sine of B, and then we're going to multiply that by 2.5, and then we're going to divide by the sine of 45, divided by sine 45, and that comes out to be 0.79. I guess they're 0.79 miles away. Is that a reasonable number? Yeah, 2.5. Yeah. 0.798. What do we want to round to? Round to the nearest tenth. 0.8. Okay, so they're 0.8 miles. 0.8 miles from camp. All right, we wouldn't want the whole deal because they didn't end up over here. Because how do we know that? They didn't walk in that direction. They walked in a, what did it say? A southwesterly direction. So down here, they're walking in a southwesterly. This is south, right? South. And then that's west, and this is east. If they walked in a southeasterly direction, then they'd be going over here. You see how this problem here in this year was way tougher. This one, not possible because they didn't give you the right information. And then it's way tougher than this one. This one didn't end up being that bad, I didn't think, because it was an angle side angle situation. So I'll try to let you know on the final you're going to take for Friday. Is it an ambiguous case or not? All right. Hey, thanks for watching my video on problem number 2.